Welcome to this expert-level training module on implementing generative AI applications and agents. Today, we are focusing squarely on how to create and test a single agent solution directly within the Microsoft Foundry portal. Welcome to this expert-level training module on implementing generative AI applications and agents. Today, we are focusing squarely on how to create and test a single agent solution directly within the Microsoft Foundry portal. Before we click a single button, we must understand a fundamental architectural shift, moving from raw generative AI models to agentic AI. When you use a generative AI model on its own, like a raw GPT-4 or Claude deployment, you are accessing pure, isolated intelligence. You provide a prompt, and it generates an output. However, agentic AI moves significantly beyond these one-off prompts. It defines a consistent, workflow-like behavior that can be seamlessly reused across different applications, experiences, and services. An AI agent is a sophisticated software application built on top of generative AI that can actively reason over natural language, dynamically automate tasks by utilizing external tools, and intelligently respond to varying contextual conditions to take appropriate actions. In Microsoft Foundry, an agent is a meticulously packaged, highly reusable AI component that brings together three critical elements. The first element is the large language model itself, which serves as the agent's brain for understanding and reasoning. The second element is the system instructions, which act as the foundational job description defining the agent's exact role and boundaries. The third and most transformative element is the tools, the specific actions and knowledge sources the agent uses to interact with the outside world. By combining these three elements, you transform a passive language model into an active digital worker capable of breaking complex goals into structured steps and maintaining working memory during extended conversations. Throughout this intensive module, we will explore exactly how to configure these three elements in the Foundry portal, test the resulting agent in the interactive playground, and securely connect it to your enterprise applications. Mastering this creation process is an absolute requirement for modern cloud architects. While creating an agent in the portal is a UI-driven process, understanding the architectural distinction between a raw model and a packaged agent dictates how you will eventually write your application logic to interact with the Foundry backend services. Take a look at the flowchart on your screen. It visualizes the transition from a raw model to a digital worker. The very first step in creating a single agent solution within the Microsoft Foundry portal is establishing its core reasoning engine and its operational boundaries. This begins with selecting the foundation model. Foundry provides an extensive model catalog featuring thousands of models, including Microsoft's proprietary models, the GPT-5 family optimized for multi-step reasoning, Anthropic's Claude Opus, and open-weight models like Mistral Large 3. Your selection dictates the raw intellectual capability of your agent. Once you select the model within the agent creation interface, you must define the system instructions. This is arguably the most critical configuration step. System instructions form the system prompt that permanently defines the agent's role, its behavioral style, its operational constraints, and its strict output formatting rules. You must think of this as writing a highly detailed job description for a new employee. For example, instead of leaving the model unconstrained, you might write, "You are a highly helpful enterprise scheduling assistant. You must always return answers in concise bullet points. You must maintain a formal corporate tone, and you are strictly forbidden from discussing topics outside of calendar management." This instruction set runs invisibly in the background, aggressively governing how the model interprets all subsequent user inputs. The generative AI model utilizes these instructions to understand its specific purpose within your enterprise architecture. A poorly written system prompt results in erratic, unpredictable agent behavior, whereas a highly specific, constraint-driven system prompt guarantees reliable, professional execution. By locking in the foundation model and the system instructions, you establish the baseline identity of your AI agent, preparing it for the next critical phase, integrating external capabilities. This careful configuration ensures your agent aligns perfectly with responsible AI principles before any code is written. System instructions are stored securely within the agent's configuration state in Azure. Unlike dynamic user prompts passed via your application's front-end chat box, these system instructions cannot be easily overridden by the end user, providing a rigid security boundary against prompt injection attacks. This diagram breaks down the initial configuration phase. During Foundry agent creation, you first select the foundation model. While a foundation model and strong system instructions provide an intelligent conversationalist, what truly sets an AI agent apart is its ability to take action. In Microsoft Foundry, this is accomplished by adding tools. If the language model is the brain, tools are the hands and sensors the agent uses to interact with the digital world. Tools represent callable capabilities that you explicitly grant to the agent. Without tools, a model can only generate text based on its pre-existing training data. With tools, an agent can execute workflows, read and write files, search the public web, update corporate databases, and integrate deeply into your enterprise backend systems. In the Foundry portal, you can centrally discover and manage these capabilities using the Foundry Tool Catalog. When you enable tools within the agent configuration interface, the model can actively inspect the available tools and autonomously decide when to call them based on the user's request. For example, you might equip your agent with a code interpreter tool for complex data analysis, or custom API functions that trigger backend microservices. Crucially, Foundry supports the Model Context Protocol, or MCP. MCP is an open standard that acts like a universal adapter, defining exactly how AI agents connect to external tools without requiring you to write custom integration code for every single service. By connecting your agent to an MCP server, you instantly expose a vast array of standardized actions. When a user asks the agent to perform a task, the agent's reasoning engine evaluates the request, determines that an external action is required, pauses its text generation, formats a structured tool call, executes the action, and then uses the return data to formulate its final natural language response. When an agent invokes a tool, it communicates using strictly formatted JSON schemas. The agent's neural network generates a payload containing the required function arguments. The backend infrastructure executes the associated Python script or REST API call, and the resulting JSON data is fed back into the agent's context window. Observe the tool execution workflow. A user request enters the agent reasoning engine. The agent determines if an action is required. If yes, it selects a tool, executes the task via the MCP server, and returns the data to the agent. This enriched context allows the agent to generate a highly accurate final response. Beyond taking actions, an enterprise-grade AI agent must base its reasoning on accurate, up-to-date, and highly secure corporate data. This brings us to the integration of knowledge. In the context of Microsoft Foundry, knowledge refers specifically to the documents, datasets, and internal sites provided to the model so it can retrieve highly relevant context during text generation. This architecture is known as Retrieval Augmented Generation, or RAG. Rather than retraining the massive foundation model on your private data, which is expensive and poses security risks, you connect the agent to a knowledge source. Foundry utilizes retrieval pipelines to systematically ingest and index your content, creating searchable vector representations of the text. When a user asks a domain-specific question, the agent searches this index, retrieves the exact paragraphs containing the answer, and grounds its response in that retrieved factual data. To manage this securely, developers utilize Foundry IQ, which provides a permission-aware, multi-source knowledge layer. Foundry IQ allows you to connect diverse knowledge sources, such as internal PDFs in Azure Blob Storage, SharePoint sites, or OneLake repositories. When the agent queries this centralized knowledge base, Foundry IQ uses agentic retrieval to break the question into optimized subqueries, searching multiple sources in parallel. Crucially, it strictly enforces user permissions and Microsoft Purview sensitivity labels, ensuring the agent only retrieves and returns information that the specific requesting user is legally authorized to see. Furthermore, when knowledge is utilized, the agent automatically includes detailed citations pointing directly to the source documents, guaranteeing transparency, traceability, and enterprise trust. Foundry abstracts the complex pipeline of chunking algorithms and vector embedding mathematics. By connecting a knowledge source via the portal, the platform automatically maintains the synchronization between your raw storage buckets and the searchable AI index, drastically reducing back-end engineering overhead. This visual demonstrates the knowledge retrieval process. A domain-specific query triggers Foundry IQ agentic retrieval. It searches multiple sources like Azure Blob and SharePoint simultaneously. It retrieves the permitted context to ground the generative output, ultimately delivering a flawless response complete with verified citations. After you have meticulously configured your agent by selecting the foundation model, writing the system instructions, and attaching the necessary tools and knowledge sources, you must rigorously validate its behavior. This critical validation occurs directly within the Foundry portal using the Agent Playground. The Playground provides a highly interactive, web-based chat interface that allows developers and business stakeholders to actively test the agent without needing to write a single line of client application code. In the Playground, you submit natural language user prompts and observe exactly how the agent responds. Because agents utilize probabilistic reasoning to orchestrate complex multi-step tasks, empirical testing is absolutely essential. You must verify that the agent successfully interprets the user's intent, correctly formats its tool calls, accurately queries the connected Foundry IQ knowledge base, and strictly adheres to the tone defined in your system instructions. If the agent struggles to use a specific tool, or if it hallucinates information instead of retrieving it from the authorized documents, you can immediately adjust the system prompt or tool descriptions right there in the portal interface. You can rapidly iterate, testing different edge case inputs to ensure the agent maintains its working memory during a prolonged conversation, and safely handles unexpected or malicious requests. The Foundry Playground abstracts the monumental complexity of underlying API calls, providing instant visual feedback. By exhaustively vetting the agent's performance in this safe sandbox environment, you absolutely guarantee that it will behave predictably, securely, and effectively when deployed into production. The Playground interface frequently includes a debug or trace panel. This allows engineers to see the raw JSON payloads being passed between the language model, the MCP servers, and the vector databases in real time, providing total transparency into the agent's internal chain of thought logic. Here we map the interactive testing loop. We open the Agent Playground and submit edge case prompts to thoroughly evaluate agent performance. If it fails formatting or tool execution, we dynamically adjust system instructions and retest. Once it performs flawlessly, the agent is formally validated for production. Once you have successfully tested and refined your agent in the Foundry Playground and confirmed that it executes its assigned tasks flawlessly, the next step is to formalize its deployment. In the Foundry portal, you can save your customized model, system instructions, tools, and knowledge configurations as a unified agent resource. Saving the agent effectively packages these distinct elements into a single, cohesive, and highly reusable AI component. This is a massive architectural advantage. Instead of forcing every single client application to independently manage tool schemas, vector search connections, and system prompts, the agent encapsulates all of this complex operational logic centrally within the Azure cloud. When you save the agent, the Microsoft Foundry platform automatically generates a unique identifier for it, known as the agent ID. This agent ID is the critical routing key that your client software will use to invoke this specific digital worker. To locate this identifier for programmatic use, you navigate to the Playground view of your finalized agent, select the Code View tab, and open the .env variables section. Here you will securely extract the agent ID alongside your project's connection strings. It is absolutely vital that these extracted credentials are treated as highly sensitive cryptographic secrets. You must store them securely in a local .env configuration file or an Azure Key Vault, never hard-coding them in plain text within your application scripts. This packaged, centralized agent approach drastically simplifies your downstream software architecture, ensuring that updates made to the agent in the Foundry portal instantly propagate to all connected client applications seamlessly. When an enterprise updates an agent system prompt or adds a new API tool via the Foundry portal, that modification is applied instantly at the Azure backend level. Because the client code simply passes data to the static agent ID, developers do not need to recompile or redeploy their front-end applications to benefit from the upgraded intelligence. This diagram illustrates the publishing pipeline. We take our validated Playground config and save it as a unified agent resource, which encapsulates the logic. Foundry generates a unique agent ID. Developers extract these variables from the code view and immediately store them securely in a .env vault. In our final section, we will bridge the gap between the Microsoft Foundry portal and your custom software by exploring how to call your newly created agent from a client application. To interact with this packaged digital worker programmatically, developers utilize the Foundry Project's SDK and invoke the dedicated project API. This is fundamentally different from simply calling a raw generative model via the OpenAI Responses API. The project API is specifically designed to handle the complex state management, asynchronous tool execution, and multi-step orchestration required by agentic workflows. In your Python codebase, you import the AI project client from the Azure SDK and authenticate using your secure connection string and Azure Entra ID credentials. You then instantiate your specific agent by calling project_client.agents.get, passing the unique agent ID you retrieved from the portal. Once connected, your client application can seamlessly submit user inputs to the agent, passing structured data or natural language. The server-side agent processes the input, autonomously executes any necessary API tool calls, queries the connected RAG knowledge bases, and returns the fully formulated citation-backed response directly to your web app, bot, or backend system. This powerful architecture enables you to run highly autonomous digital workers at massive enterprise scale. Thank you for joining this expert technical training session. Please be sure to like this video, subscribe to our channel, and share this knowledge with your engineering peers. To truly master these advanced AI capabilities and accelerate your cloud career, visit quicktechie.com for our premium certification prep, featuring extensive Q&A banks, ebooks, audiobooks, and expert interview guides. Build intelligently, and we will see you in the next lesson. To execute this in Python, you initialize the AI project client using your Azure credentials. You retrieve the packaged agent using agent equals project_client.agents.get. Agent_name equals os.getenv, agent_id. You then create a persistent thread and use project_client.messages.create to securely submit the user's natural language request into the agent's processing pipeline. Our final flowchart maps the programmatic integration. The Python client application initializes the AI project client SDK and authenticates. It gets the agent using the unique agent ID and submits the user payload.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.